Well, a warm welcome to anyone joining. Thank you for being here. Go ahead and get yourself ready with a notebook, grab a pencil or a pen. Whatever you choose to write with is fine. This is math in void. Math coming at you pretty much out of nowhere. And today we have a problem involving inverses. We're going to take a look at the slope and the relationship of the slopes between two functions f and g, which are inverses of each other. Okay. Now go ahead and give yourself about 4, maybe 5 minutes to work this problem out for yourself. It's got 3 parts, so it could take, a few minutes. Give it a try. Do your best. I'm sure you'll do fine. And then when you're ready, unpause the video, come on back, see how we did it here. Okay, now it does specify in the problem that f of x is a linear function, and it passes through these 2 points. So we're given 2 points to consider, and g is simply going to be its inverse. Let's begin with finding the slope of f. We don't even really need to get the equation for f in order to do this. You'll notice that to find the slope of f, which is a linear function, we just need to simply use the average rate of change or the typical slope formula that you would have learned in algebra, like rise over run, right? So maybe we can call this I'm going to call this m1 because we're going to have more than one slope rolling around. But remember that the equation for finding the slope here is y2 minus y1 over x2 minus x1. So let's use the points that we know this function goes through. And that's going to be using 3, 3, and -1, -5. So this would be 3 minus -5 over 3 minus -1, which gives us 8. Maybe I should show all my work. Gives us 3 plus 5 and 3 plus 1, which does give us 8 over 4, or simply 2. Okay, easy enough, right? Very easy to find the slope of a line that passes through 2 points. You just use the rise over run formula. Now, how are we going to get the slope of g specifically without finding g of x first? Well, we need to use the fact that g is the inverse. And what we do with inverse is we swap the input and the output. And then we need to find the new slope between these 2 points. So that means that the first point is going to go from 3, 3 to 3, 3. It actually doesn't change much at all. Right? If we swap 3 and 3, it just stays 3 and 3. And then we're going to have -5, -1. So you might be able to notice what that does to the slope. Let's calculate the slope now. So I'm going to call this m2. This represents the slope of g. This is going to be 3 minus -1 on top now. 3 minus -5 on bottom now. So that's 3 plus 1 over 3 plus 5. And that gives us 4 over 8, or 1/2. So what do we notice about those slopes? They are just the reciprocal of each other. Very interesting. And this is kind of a fact about inverse slopes, is that steep slopes, they get lazy. So a slope of 2, something like that, this steeper slope is going to get lazy when we do the inverse. It's going to have a slope of 1/2. See how it got lazier? Fell down a little bit. It's not as upright. Okay, and the last part of this is to find g of x in simplified form. So this comes down to being able to write a linear equation. And we do have a point. We have 2 points to work with, actually, for g of x, and we have the slope. So we could use the point-slope format. What is that going to look like? It's simply going to look like this. Y minus the y value equals the slope times x minus the x value. And you'll notice this basically comes from the slope formula. If we were to take this slope formula, multiply both sides by the quantity x2 minus x1, that is exactly what we would have here. We would basically have this point-slope equation. So let's use any of the points. I think the easiest one to use is 3, 3. It's such an easy point to work with. And there we have it. This is the point-slope form of the equation, which you're going to need in calculus quite a lot. You use point-slope form often. Now, if we wanted to put this in slope-intercept form, we could also do that very easily. All we would have to do is basically solve for the y, get the y value by itself from this equation. So we can start by opening up the parentheses 1/2 x minus 3/2, and then we can go ahead and add 3 on both sides to get the y by itself. So plus 3 on the left side is going to balance that out, cancel it out, and then we're going to have 1/2 x. What is a minus 3/2 and a plus 3/2? It's just a plus 3/2, right? Because this is half of the 3, and this is a whole 3. So if I take a whole 3 and subtract a half 3, I'm left with the other half, the other remaining half of 3. And this is our equation in slope-intercept form. We didn't find the function for f of x, but it would be pretty easy, and we'd be able to notice that the slope is indeed 2. What can we say about this slope? We know that this is the slope. We can confirm that this is the slope because in a slope-intercept form, we use the format y equals mx plus b. So as a bonus, I would like to offer the opportunity to precisely sketch this situation. I kind of roughly sketched it, but I'd like you to use the points on a grid and actually draw the line between the points. And you can see for yourself that the steep slope of 2 turns into a lazy slope of 1/2 when we consider the inverse function. And when you take calculus, you'll definitely learn that there's an interesting relationship between the slope of a function and the slope of its inverse. This was a quick little linear algebraic situation, some prep for calculus since that time is coming right around the corner. Alright, that's enough blab out of me. I'll see you guys next time.